Hi, everybody. Hey, in the set puzzle, we figured it'd be great to take a day to examine when should I use certain methods. And I think I'm going to get rid of myself here today. So bye, my happy face will disappear. The muscle in the way. Okay, and this is what your goal is. Your goal is to be efficient. Now, I know some of the other teachers lamented, like I did over the last little quiz that we had here, kind of an eye-opening experience where some of you guys are at and the work that we're going to have to start putting in as far as getting things figured out. And this is what this day is about. When should I use what method? Don't become using like the quadratic formula as the end all be all and now it's your savior, so I never have to factor again. No, factoring keeps coming up in so many different cases. You better get this figured out. So here's the idea. I have a quadratic like A, B, C, and D. We really should go ahead and do factoring as the method to solve. So looking at this first one, don't mess this up. This is a GCF kind of factoring. And then using the zero product property. Guys, we got to get this figured out. Because fast and efficient, we end up getting two answers without having to use that quadratic formula and it takes multiple steps. Yes, we need to know how to factor and remember a difference of two squares. I know many of you are there. Many of you got it. There's a handful that's got a lot of work to do. And then if we use the zero product property, I shouldn't have to keep writing this, but this is what the zero product property says. If this times that equals 0, then either this or that equals 0. Add 5, divide by 2. Shouldn't have to show those undo operations. Subtract 5, divide by 2. And then that would be it. Much faster than the quadratic formula. We can't factor this. Ay, so sad. What multiplies to 6 and adds to -5? -3 and -2. Good FOILers, good factors. X squared, -5x, +6. And then we should be able to skip to x equals 3 and x equals 2 are the zeros, the solutions coming from those factors. And then last but not, all right. Now this one, maybe if I said to solve and you use the quadratic formula, I guess I would allow it because the m number, geez, I have to pick up my own calculator. -180, ay. What multiplies to -180 and adds to -11? Yikes. I actually will help you out on this. You really focus on this. Oh, hey, that looks like a smiley face. Let's go back. You focus on the add numbers and then you get your calculator out. Actually, I'll have that happen. Oh, great. I love how long this takes. Great for the video. La, la, la. Let's sing the quadratic formula song while we're waiting. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Hope the other math teachers sang that song to you. But anyway, all right, so I was keying off of, what is going on here? Oh my goodness. I want to reduce the size of my screen and it won't let me. Okay, -11. Okay, -11. I'll move this down a little bit here. So you want numbers that add to -11 that multiply to -180. So what adds to -11? Like -15 and 4. Well, that's kind of a ridiculous choice because that's not even close to -180. So what I got to do is go up, like maybe -17 times what adds to -11? 5. I can't think. 6. Those add to -11. Ooh. Times 9. I should have known that. Oh, how embarrassing. But anyway, it works. So sorry that took me so long. And then what do you do about this? We need to review this anyway, because we're going to make you factor as like maybe a section on the test. And you got to go through that process. And then when you finally find the magic numbers, I apologize for how long that took me. You split up that middle term into those magic numbers, and then you factor by grouping. Okay, so we need this. We saw some big problems on individuals' quizzes that don't know still how to factor like it's day one. To a 4, 8, 12, 6, 8, 4 goes into both of these. 3x minus 5. And then 3 goes into these. 3x minus 5. That's proof that I found the correct magic numbers. I apologize for taking so long on getting those, but hey, gives you time. Okay, now, zero product property. If this times that equals 0, then this or that equals 0. And then you solve. I really hope you get good with this. Add 5, divide by 3. Subtract 3, divide by 4. Okay, so maybe the quadratic formula would have been a better choice on that tough factoring. No way. These first 3 we should be doing by factoring. You'll be much faster, and then you won't run out of time on tests when we say there's no extra time. You absolutely, positively should not be using the quadratic formula on this one. By the way, B would be 0. Because really, all you got to do is subtract 12. And then root both sides. Do not forget that you get plus minus, and then root -1 times root 4 times root 3. Should have given myself a little space on this one. So x equals, I'm in the here, plus minus. What a mess. I don't want to go here. X equals plus minus. Square root of 4 is 2. Root 3 stuck in jail. I. That's the answer to letter A. Letter B, wait a minute. Letter B is letter B up here. I should solve by factoring. Sure, but I did this on purpose. You also could have, on a difference of 2 squares, added 25, divided by 4, and then square roots both sides. And lo and behold, as long as you remember the plus minus thing, how do I square root a fraction? It's simple, the numerator and the denominator. Plus or minus 5 over 2. Look at when I solved by solved by factoring a difference of 2 squares. I get the same answers. So it ain't no thing, chicken wings. Subtract 4, x minus 2 squared equals 8. Now let's analyze this one. Some people would subtract 12, then they'd FOIL this, and then they would jack that up anyway, and then they try to get everything combined together and then use the quadratic formula. That is like 8 steps. This is why students run out of time on tests, because they don't choose the most efficient method because they're not practiced enough. Maybe, as I identified in my class, students not doing the written work appropriately. All right, square root of 8 is the square root of 4 times the square root of 2. It ain't no rocket science to figure out why some people are not succeeding. Don't do the work, you got a no chance. Simple science. Okay, I did add 2 to both sides. How do I add 2 to plus or minus 2 root 2? You can't. So you just put the 2 out in front and say 2 plus or minus 2 root 2. All right, and then we're not going to do this one, but this is when I know I have to use the quadratic formula. M equals 15 and A equals -11. There are no numbers that work for that combination. So that is when you got to choose a different method. And you can't use the square root method because it's not in those situations. Okay, so now solve each equation and provide a simplified exact solution. That just means we're not going to the decimal. State the method used and the reason for using it. All right, so here we go. Zoom in on this first one. In the first one, you should definitely subtract 4x from both sides. All right, and then it's the classic, okay, should I try factoring? M equals 30, A equals -4. What? I get a positive product that equals 30, like 3 times 10, 6 times 5, whatever. and a sum that equals a -4, well, now they both need to be negative. There is nothing that exists for this. So it's the opposite of B. This is when you would do the quadratic formula. Plus or minus the square root of B squared minus 4AC all over 2A. All right, so 2 times 3. So again, understanding that the quadratic formula, even though we're not going to show you where it comes from, does actually solve and get solutions. It's our last ditch thing that we should try before other methods are investigated. 16. Ooh, -4 squared is positive 16. Watch when I'm a calculator bum pusher. When I just go, I don't want to even think. I'm just going to go -4 squared and press enter. -16. And I'm going to write -16 in here. Wrong. You're not even thinking. And we must think. 4 times 3 is 12. Times 10 is 120. Oh, no. We're going to get that nasty I number situation. All right. And then 4 plus or minus. Let's just get down to it. Square root. Move this up. Of -104 over 6. In my class, remember, we take 104 off to the side and start breaking it down. Whoa, 52, and then break down 52 again. 2 times 26, I think. Another 2 times 13. Okay, well, I only have one perfect square, so this is how I'm going to rewrite this. 4 plus or minus. Oh, by the way, square root of a negative. Square root of 4. And then square root of what's left over? 26. All over 6. And then this is 4 plus or minus 2 root 26 I. I from this, 2 from this, right? All over 6. And then we have one reduction we have to do. Oh, I got space. I don't know what I'm being so stingy with the space for. You can split this up into 2 separate fractions. Or you could skip this step and just understand that 2 goes into all 3 of these. 2 over 3 plus or minus root 26 over 3I. And that's how we kind of like you to write it. It could be up in the numerator with the root 26. Make sure it's not underneath that radical. We can't stand that. And picky math teachers, probably like myself, would my hand would start shaking with the red pen wanting to mark it wrong. Okay, so A equals 1, B equals -8, and C equals 0, but a waste of time to use the quadratic formula because this is just like what I showed you up in the notes section. This is factoring out a GCF, and then this is zero product property. So K equals 0, K equals 8. All right, and done. Look at how long my last example took. Look at how quick number 2 got done. Those that rely on the quadratic formula will never, ever, 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 ever finish one of our tests. That's why you must listen in class. You must do your work in order to succeed. Okay, use the quadratic formula on this one. You're causing yourself some major issues. Oh, I already see something that's going to happen with this, though. 6n squared equals 15. Then we're going to divide by 6. This one might be a little out of place because we have not talked about how do we deal with radicals in the denominator. By the way, it's plus minus, and I should have reduced that fraction before. 3 goes into both. 3 goes into both 15 and 6. Sorry. Now, what do you do after this? I guess I'm going to wait on this. I don't know if you've seen rationalizing a denominator before. So as of right now, I think we have to allow this as an answer. I'll have to confer with my other math colleagues and see if you did do that last year. Something to come up with, you know. Okay, and then looking at this one, well, let's think of an MA situation here before I go to the quadratic formula. Is there or are there two numbers that multiply to negative 45 and those same two numbers add to negative 12? Probably going to ed puzzle you on this one. What are those two numbers? They actually exist. All right, I stalled so I can ed puzzle it. It's negative 15 and 3. So I'll write those down in the classic, how do I factor it when it's 1b squared? You basically have the factors already done. B minus 15b, so negative 15 and positive 3. Then good FOILers, good factors, b squared, 3b and negative 15b, darn tootin'. Negative 15 times 3, negative 45. I still believe people cannot FOIL because I have people that cannot factor. Get on the bus and get this figured out so that we can proceed on, because we're not going to wait for you, man. We got enough people that know what's going on, so it's on you at this point. And that probably goes for all three classes, because I've already talked to your teachers as well about this, about getting the job done here, doing the work that you're supposed to be doing. All right, so here, let's talk about this one. Some people might be inclined to subtract 15, might try to FOIL this, and might try to get some x squared plus some bx plus some number equal to 0 and try the quadratic formula. They do 4 steps of work to get to here, and then 4 steps of work to do the quadratic formula. And no way, that's why we covered this first. Whenever we see this, this should automatically stick out like a sore thumb that we're going to solve by square rooting. So we're actually going to add 3. And I think we're going to end up with a situation again that we weren't really wanting you to do as of right now. So I should have adjusted these questions to not have square roots in the denominator for the moment, because that's one of the kind of missing things in our curriculum at this point. So I'm going to not reduce that 18 over 4, and here's why. Square root both sides. When you square root a fraction, all you have to do is square root the numerator and square root the denominator. And then what this gives me is plus minus. Don't forget that. Square root of 4 is 2. Okay, and again, it's plus minus. I shouldn't, my other math colleagues are going to be mad at me. It's because the absolute value of x plus 2 equals the square root of 18 over 4. And then because of the definition of absolute value, you put plus minus. But basically, you got to remember it's plus minus whenever you square root both sides. Then we're going to subtract 2. And this would be an acceptable answer for this. I don't want to scare you, but it really is just my 10-year-old would know this. Negative 2 is the same thing as negative 4 over 2. You should be aware that this could be written as negative 4 plus, oh my gosh, I'm making a huge mistake. This actually is square root of 18 reduces. So let me hold off on that. Plus or minus, and then we should be fast on this. This is 9 times 2, so it's 3 root 2 over 2. Okay, square root of 9 is 3, and then 2 gets stuck in there. So careful how I wrote that fraction, because it almost looks like it's getting close to that negative 2. Okay, then to finish what I was saying, my daughter knows, my 10-year-old, that negative 2 equals negative 4 over 2. So another possible iteration of this answer would be negative 4 plus or minus 3 over 2 all over 2. You get worried about multiple choice tests, and sometimes they won't have this listed, but they will have that. This should not be a big deal. All I did was got a common denominator, and then I put them all over the common denominator. So I added negative 4 plus or minus 3 over 2 all over 2. Then last but not least, yikes, I got parentheses. What's this garbage? Distributes. That equals -9 minus 6k. No matter what method you use. Now, this isn't the square root method. If you tried to factor or quadratic formula, you must get it equal to 0. That's 6. Add 6k. Oh, well, look at this. This is nice. So even if you were going to use the quadratic formula or try to factor, oh, I just made a mistake. Obviously, this isn't going to be the square root method. I was completely and totally wrong. Because using a quadratic formula would be a waste of time. So actually, I'm going to go ahead and flip this 6 over to the other side again. What the heck? Oh my gosh. Divide by 6. Ooh. And then square roots. Hey, what does that answer become? Plus minus. Remember, square root of k squared is the absolute value of k. Equals the square root of -1. Ooh, and what's the square root of -1? I. So k equals plus or minus I. So not quadratic formula, much faster. Once I lost my middle term, hey, that's one where I just want to solve by square rooting both sides. So now I went ahead and subtracted the 6 again, divided by 6, and we're good to go.